So you can see the screen now. Answer yes or no.
Yes, yes, yes.
You can see the screen. You can see the command prompt as well.
Yes, we can see it.
Yes.
Okay, good. So which means you can see most of the things that we need. CD, Java, Sunday. Okay. So this is our program today, Java K session 0801.java. This is our program, and we have something. Okay. So yeah, something is missing from our notepad. You can see parentheses here. We save. We needed to close the parentheses here. So execute. So many errors. So many errors. Don't worry. So now let's see. Number one, no static method display cannot be referenced from a static method. Okay, so since we are calling this from a static method, there needed to be static class as well. So can say like a public static void, public static, and the public static. All right, save again. So we compile here. Okay, missing return statement on which line? Line number 12. We don't have return statement. Where is it? Yes, because this is this is int. We need to return integer value. Eventually, what we needed here was something like return C. Return C. If you want, you can even still display it, but you needed it to return. So if we return C, that means here we can have another variable like int E. Then we say E equal to sum, because the function returns. Then here we display the value. That's fine. We do system out print line first sum method returns something. What is that? It returns E. And the second returns D. So let's save. Let's come here. Now it's okay. We can do Java session 0801. You can see the output. The main method, this is the main method. This is the first method, which is display name. This is the second method, which returns a number with no parameter. And this is the answer from the third method, which returns integer, 50 plus 30. All right, this is one of the example. We have a method which returns, okay, and which takes some parameters. We have a method which does not return with no parameter. We have a method which does not return and it takes a parameter as a string. We can add the method which takes parameter as a string. Like here, you can say, let's add another method to display a name as a parameter. Public static void display given name. So this method will display any name that you pass here, and we pass this as a parameter. Okay, given name. So we can display this method, this name here. Given name is, simply put given name. So we make a call to this method. So how do we make a call to this method? You simply say display given name Alex, for example. So this name Alex will come here and it will be used here. You will see the message like given name is Alex. So let's save again and come here and compile and check the output. You can see. So I think you understand the basics of those methods as of this slide. Then here we have a method. Yes, this is very interesting. We have a method which it takes array of integers and return something. So let's use this signature, and we need it to work out on how you can return the largest number. You see the method signature? So we need to write a code here. For any array of elements you pass, you need to find the largest. Okay? So what is the algorithm? So let's say you will have to iterate. Let's say you have one integer, which is the largest. Have the same, okay, yeah, largest, that's fine. You have integer, we have a variable. You can give it any name. Okay, let's say biggest number. So you have integer, which is the biggest. And initially, this can be the first element in your array. Then what you do, you have to iterate. Let's check if our algorithm will work. Int I equal to 0, I less than, we need to know the length of this element. I mean, we need to know length of our array. Elements dot, how many elements are there? We don't know, but we can ask this to tell us how many elements. Yes, if there are 5 elements, length is 5. If it is the 3 elements, length is 2, whatever. So then I plus plus, how do we check the largest number? You will say if, all right, with this work, let's say if element at position I is greater, is less or equal, it's less than element at position I plus 1, what you do? Again, you swap those elements. You will say biggest element equal to elements at the position I. This is a simple algorithm. Okay, we can test this one and see. Let's try like this one. Let's say you have these 5 elements. You have got 10. Sorry. Can you see? Let's say you have 10, you have 20, you have a 15, you have a 30, and you have maybe 25. So initially, the biggest equal to the first element, which is 10. Then for every iteration, you check all these elements. If this element is greater than this one, the biggest should become this element. Otherwise, it remains this one. Okay? So now if you check the first element, and the first element is less than the second element, the biggest remain the first element if the first element is greater than the second element. Otherwise, the biggest becomes the next element. So this is the idea that we need to work out to make sure that we get our algorithm to work. So if element at position I, eventually I should do this. If element at position I is greater than element at position I plus 1, biggest element is the element at position I. Otherwise, nothing will happen. Then it moves to the next. So we can make a call to this method and see what happens. So again, remember, we are going to call array, to call a method which array of elements. So we need to declare array, something like int unsorted. No, okay. Our array, doesn't matter the name you give. So you can put this argument here and they put some values if you want, like a 20, 40, 48, 8, 100, 10, 30 or 60, something like this one. So this is our array of elements. And this array is not sorted. If you want, you can check the elements you have in your array. But when we make a call to our array, it will, we need to pass this array as well. So let's say we have another collection, another array. No, we don't need array actually. So we need the largest. We need the largest number, which is integer. That will be the next example. So when you make a call, I will say, all right, largest will be equal to, I need to make a call to my array. My array is the largest, and I'm going to pass our arrays. So it takes a collection. So then let's ask our program to see what is stored in the largest. So it's an algorithm that we don't know if it gives exactly the largest number, but that is the basic idea to go with. Number one, our arrays cannot define the symbol. How did we define it? Our array. Oh, it's our array, not our arrays. So we remove S here. Let's see. Okay. Yeah, it has to be static method as well. Int static largest. Okay. So the reason is we are calling this method inside the static method. So they must be static as well. That's the point. If you're not calling them inside the static method, we should not worry about making them static. So we come back to those access modifiers as well. So now let's see. Missing return statement. Okay, which one should return? Yes, here we have int. So after this loop and this if, we should return. So what we return the biggest. All right, so now let's go. Okay, now let's look at what is the output there. Okay. What is that? Oh, array index out of bounds exception. Yes, great, great. What does it mean? Here, when you compare the last element, let's say the length of our array is 5 elements. When we do I plus 1, we get 6. So we don't need to go up to there. We need to go to one position below. Okay, because when I'm on I, it will compare I with I plus 1. Okay, so if you go beyond that, you'll be accessing elements which does not exist in your array. All right, let's check it now. Now it's okay. We can see we still have an array index out of bound exception. Where is that? Because we have, okay. Okay. Oh, I said less or equal. No. It's a big mistake. You should do the length minus 1 actually, because I think if you don't understand why we do this minus 1, please let me know. So rather than saying less or equal, if the final element is at position 5, if I do, if this is my I, okay, first, this is the final element at the position 5. Position 5. That means we have a 6 element. 6 elements in our array. So then if I compare element at position I and I plus 1, it will be comparing element at the position 5 and the position 6. The element at position 6 does not exist, so it's comparing here. So we go until we go to total length minus 1, which means the final I will check will be when I equal to 4, then I equal to I plus 1 will be 5. So it will be able to compare the second element from the last and the last element. So that's the point I'm trying to make here. So let's remove this one. Or you can make it as a comment if you want. If you don't know how to make a comment in Java, you can comment it like this one. That's a comment. So you come back again. Okay. That's it. So is 200 the largest number? Let's check. Definitely 200 is the largest number. Okay. Let's put another number like a 400. Will 400 be the largest number? Let's check. Should be. Okay. 200. Did we save and compile? Let's see. We saved. So our algorithm doesn't work because the largest element should be 400. Should be 400, not 200. If it does not work, let's say if element of I is greater than element of I plus 1, the biggest element is element at I. So if this one does not work, let's go with 2 loops. So this is the outer loop. Let's bring the inner loop. Yes. Length. Okay, I will tell you what I'm trying to do. So we do another. So we have another, this is 2 loops. We close, if we close one loop, we close another loop. So we're trying to compare the elements from the outer loop and the elements from the inner loop. Then what I will do, this can be up to total length -1, that's fine. That will be up to, oh no, we can go with G from 0, G less, or we can do G start from I, and we go up to the length, that's fine. Then we compare element of G, element of I, that's fine, and element of G. Okay. So excuse me for 2 minutes, please. So I'm back, guys. Oh, sorry. So I need to finish this logic. So we can do the largest element as, no, we don't need even this one. We can have like, let's see. So I start from 0, I less total number of elements. Just start from I. Eventually should start from I plus 1 because it needs to check 2 consecutive elements. But here we don't need it to, when it starts from I, from 0, sorry, needs to go up to the total number of elements. And this will start from I plus 1 up to the total number of elements. Then if element at position I is greater than element at position G, so I will do, so we can assume that the biggest element is element at position I. But what after? So let's remove this comment here. Let's remove this comment here. Element at position I greater than element at position G. The biggest will be element at position I. So let's see what we get. We are not interested in other methods, only the method to return the highest number. So something is wrong still, but are we compiling the same class? So biggest element, okay, text element at position 0. We don't need this one. So let's make it simple and complicate, not to complicate it. We don't assign it to be the element at position 0. So then here, biggest will be element at position I. Then we need to, okay, now we can make it simple. We need to swap, but the swapping will be a very long process, but still will give us the results. So if you swap elements at each position, biggest will be element at position I, then element at position, at which position? I, let's see. So this can be the best way to do it. But normally, what you do when you introduce the concept of swap. Okay, I see in a PowerPoint here. Let's think of this algorithm, because you have got how many elements we put in. Sorry guys, so someone was calling me. Let's see what we have. I don't know what is, okay. So let's see what what you are doing. What is wrong here? Okay. biggest. So if biggest, okay, if element at I, okay, sorry. Eventually we made it very complicated for nothing. So let me remove this inner loop again. And I should remove also this parenthesis here. So for I equal to 0, and we assume that this is the first element as we did before. Element at position 0. Then I from 0, yeah, up to the length -1. Yeah, this was my mistake actually. Yes. If element at a particular position is greater than the biggest, all right? If element at any particular position is greater than the biggest, then we change the value of biggest from that position. Okay, we change the value in the biggest to the number which is greater than the biggest. So we don't even need these two statements, I think. So let's try this one. It was simple, but I don't know how I ended up making it complicated. So I'm hoping this one will give you the right results. Okay. Yeah. True. So I was complicating it. I don't know for which reason. So this piece of code can return the largest number. But our focus here was on how you can pass array of integers. And from this array, you can do anything you want. You can return the largest number. You can sort this array, but sorting will be different algorithm. So let's assume we use the same class and we sort the numbers. We return a sorted array. So this is not the largest. This is a sorted array. Let's call it a sorted array. So we don't need this. We don't need this one. Let's see. So now for sorting array, and what we needed to return here, we return sorted array as well. So we return sorted array. So for any given array that we pass, we can navigate it through and return the sorted array. Okay. So definitely to sort arrays, we needed two loops. So for every element, we compare it with the next element. Less than elements dot length th, then g++. How do we sort array? The sorting will come here. Of course, we need to check the condition. If elements at position x is greater than element at position x plus 1, because we have a value which is a value of I plus 1. We need to do some swap here. We need to do some swap. And when we swap, we need the temporary element, temporary variable to use. How many loops, how many parentheses? 1, 2. Okay, we don't need this one. 1, 2, 3, and this one, 4. We need another one. Sorry. This one, we close. This one will close this. No. This one is closed here. I think it's very important to have a notation which allows you to know which one is open, which one is closed. And this one is closed by this one. Okay, so we have more. So return will come here. So what are we going to return? We return the sorted array. If you want to make it like this one, we need to return. So this is fine. Two loops, one if, and of course, one if, yes. So now, since we are sorting, we need the temporary variable. So if element at position I is greater than element at position G, so what we do, we store, what is the biggest number here? Because we're going to swap these two numbers. Let's go with the temp equal to element at position I, then element at position I, we put there element at position J, then at position J, we put element which was stored in a temporary variable. So in the end, do we need, okay, let's start with a simple one. We are not going to return sorted. We simply sort those elements, and probably we can check if we are able to sort them. After this loop, we have a sorted array. We can do for int I equal to 0, I less than elements dot length, then I plus plus. We can check if elements are sorted. Okay, system out, print line. We do element of I. Can put some, eventually this is a print line because we don't need to have each element on its own line. Maybe we can do some space like this one. So let's make a call to this method as well. So we call sorted arrays and we pass as our argument array. So what we are passing here is this collection here. So if our algorithm works well, we come here and sort those elements. Let's see if we can see the sorted elements. Then we can use the same concept to return array of sorted elements. Let's check first. Okay, let's see what happens after compiling. Cannot find the symbol. Which is symbol? Sorted arrays. I don't know what should be the name. The name is the sorted array. Then here we should not have a S. Sorted array. Okay. Let's see. Then let's see. All right. So you can see our algorithm works perfect. We can have a collection. We can have our arrays sorted. So what we can think of now is to make sure that we have an array, we have a method which can return sorted the array. This is just a sorting. You can modify it a bit. You can modify it maybe we put it 2, and this time around, we want it to return. We want it to return a collection, or we want it to return array of sorted element. So what we need to do, we need also to declare another array here. Or maybe we call it sorted array. Sorted one, doesn't matter. So as you can see, there are so many ways you can do that. If we can have elements sorted here, why not having sorted one here at whatever position, and we put that element as well. So I think with this one, in the end, when you finish iterating this element, what you have in the sorted one will be a collection, will be array of sorted element. Then you can have your return here, return is sorted one. So I think this one it's okay based on the previous one. Rather than displaying those elements, we store those elements in another array called the sorted one, and we can return that array. You can return array of sorted one. So then in your program, how you call it? If you need to call this array, yes, there are so many ways you can call it. Let's have another array here. Int sorted. So since it returns, we'll say sorted equal sorted array. I think what did we use? Sorted array 2, like this one. Sorted array, and we add 2, but of course we remember to pass this array, which is here. Then if you want, you can iterate through this array. So many ways you can iterate, but the most used one is just a simple normal loop. I erase or equal to, what is the name? Okay, it's called sorted now, sorted length. Int I equal to 0, should you say I equal to 0, then I plus plus. Then, of course, you can say system out print. Then it's a sorted I. If you want, you can put some space between those elements. This one should be almost the same as the previous version. Let's go ahead and see. Okay, let's compile. Variable sorted one might not have been initialized. Where is it? Variable sorted one, where is it? Okay, let's check the line number. So, okay, return is sorted one. I think it's in our method. Let's see here. Okay, sorted one might not been initialized. Okay, return is sorted one. So we needed to initialize this one before we return it. We return the value, we return it as, okay, what could be the initial value? So the initial value that we can give sorted one, let's give it, doesn't matter. Yeah. Let's give it the initial value sorted one. So let's give even the elements. This is the array we are passing. So we initialize this one with whatever we are given, but the actual value that we put here will be the value we'll get after sorting, rearranging the elements. So let's see if this one will solve our problem here. Okay. So what is the output? We have got exception, but is it sorting 10, 20, 40, 48, 60, 80, 200, 400? Okay, yeah, they are sorting. They are sorting. But what is this exception? Let's see. Oh, array index out of bound exception. So we are going beyond. So, okay. We are going beyond. I think it's here. No, if we are comparing it to arrays, we need to not to reach the last element here. So n-1, then we go to the last index here. So we can check this one. It will solve the problem. All right, still the same. Array index out of bound exception. 93. Check. Okay, I less length d+1. I+1. Okay, sorry. No. This is okay. This was okay, but -1 should be here. So the point is, if we just start from I+1, the last element will go beyond the size of array. So we need to do this -1 to avoid having an element which is not in our array index out of bound. Okay. So now let's save this one. All right. This is oh, sorry. We still have array index out of bound exception. Which line?
So,
93.
so
Yes.
I think you may check on the last loop.
The
The
last
main
two.
function. In the main function.
Oh.
Yeah, put
No,
greater
it's
or
here.
equal.
It's here because we put or equal. Should be less. Once we start from 0, should be less, not less or equal. Or if you put or equal, then you put -1 here. So I think it's here, yeah. So this is the same loops that used in C. You can simply make a small mistake and you end up by creating those kind of exceptions. So now it's okay. We don't have that exception. The first sort, and this is the second sort. All right. So in this file, we have so many cases, complicated and easy one, but normally they're not complicated. It's me, especially on the biggest, I made it complicated for nothing, but for sorting array, it's the same as you did in C. And the sorting, but returning sorted one. Simple logic. So maybe we can take a second example, but the second example, I wanted to talk about recursive concept. So before we move to the recursive one, do you guys have some questions to ask? So are we still connected? So no one is connected, I think.
We're still connected, sir.
Oh, you are connected. Okay. So now let's discuss the concept of recursive, because we have a definition of recursive as a method which calls itself. We can have a simple one. So let's. So how do you calculate the factorial of any given number? Let's say we have a method. Can it be int or not? Yeah, public int fact, and to calculate the factorial of any given number, how do you calculate factorial of any given number? So a factorial of any given number is that particular number times factorial of its previous number. So when you do this, you have this function here, which is same as this one, but different parameters. This method, it's calling itself here. We call it factorial. But what happens with the factorial of 0, factorial of 1? Those ones are noun. That's why people will say if a equal to 0, for example, then return 1. If a equal to 0, then return 1. Otherwise, return that number times factorial of its previous number. So now let's put it in real context and see how it works. If you are given like a factorial of 2, how can you calculate it? If you are given like a factorial of 2, let's start with that one, factorial of 2. So based on this concept, it is 2 times
1.
factorial of 1. And what is factorial of 1? Factorial of 1, it's 1. Eventually, factorial of 1 and 0, it's given, it's 1. But factorial of 1, it's 1. If you want to go with the formula, it's 1 factorial of 0. And what is factorial of 0? It's 1. 1 times 1, you get 1. Factorial of 1 becomes 1. And you replace it here, factorial of 2 becomes 2. Okay? So what you can do here, you can do this, or you can say if a equal to 0 or even a equal to 1, its factorial is 1. So I think if you go this way, you can compute the factorial of any number. If a equal to 0, it returns 1. Otherwise, it returns a times factorial of the previous number. Now, let's call that method. Let's call that method. Let's say int c equal to fact of 5. What is the factorial for 5? Anyone can tell?
120.
What is the factorial for 5?
120.
120?
20.
Okay. So let's see. So, okay. No, this is a 5. The factorial of, okay, you can say factorial, okay, the factorial of given number of given number is. We can execute this. So do you guys understand the meaning of recursive method? The point is here. This is my method, and within my method, I'm calling the same method, and I'm testing it here, okay? By calling my method with argument 5. So let's check. Let's check and see what we get. 2 already exists. We can overwrite it. Now let's see if we put it 2. Okay. Yes, yes, yes. Oh my God, does not. We should not close. We should not have this one here. I think that was the mistake. Okay, and non-static method, yes, it has to be static. Okay. Now let's see what happens. Invalid method declaration, return type required. Oh, we did the reverse actually. It's a public static int, not public int static. Okay, now let's see. So now you see session is 0802. Yeah, you can see the factorial of 5 is 120. What about factorial of 6? Anyone quickly to tell? Guys, are you there?
720.
720. Let's see. $720. Cool. So this is what we mean. So now, next, let's look at the method overloading. Method overloading. So what did we say about method overloading? You have methods with the same name, but different parameters. Like you can have like a sum here with no parameter, for example, and say, let's say int a equal to 20, int b equal to 50, then int c equal to a plus b, then system out, print line, sum is c. This is one method. 2, you can have this method and have some parameters, for example. So then you say, eventually this should return. Otherwise we make it void. Okay? So here, if we do not want it to have return, we make it void. So then here we say, int a equal to x plus y, and here the sum is a. Okay, we can have the same method again with the same name, and probably give 3 parameters. Int z, and here we say plus z, then we do c. Even you can pass different type of parameters, because the point is different parameters. You can do floats. float X, float Y, and float A equal to A plus X, the sum is A. So I want you guys to understand all this method here, they have the same names, but parameters are different. Maybe in terms of number or in terms of type. So when you make a call, for example, like this one, the program understands that you are referring to this method. Okay? If you make a call, let's say to a 30, 40, which method are we calling? We are calling this method, all right? So it checks the parameters. If we do sum, something like this one, this is how we call a float. How do we assign a float value? We add F, I think, right? So then if I do like something like this one, it knows which method I'm accessing. So can you closely check this these four statements and let me know if you understand the meaning of method overloading. So guys, if you are connected, let me know. Are you connected?
Yes.
So do you understand what you mean by method overloading?
Yes,
Yes.
it allows a class to have more than one method having the same name.
They have the same name, but they can have different parameters. So if you look at this point here and this point, they have the same number of parameters, but one is taking floats, another is taking integer. So the one which is taking float, it's which is taking integer, it is referring to this method, and the one taking floats is referring to this one. Okay, let's check and see what happens. Method overloading. This is example number 3. Then in Java session 8.3. Now you can see. Okay. So I think it's okay. Now the last point to discuss here before we end up, it's a concept of passing unlimited number of arguments. So we can maybe keep one method here and see what happens when you want to pass unlimited or unspecified number of arguments. So what do we mean by unlimited number of arguments? So I remove all of them. I remove all of them here. Okay, public static void. I remain. So it's a sum of what? Whatever the numbers you will pass, you want your program to find the sum of those numbers. So if you remember the last slide, we said that we use ellipsis, and this is the name of your argument. You can give any name, okay? You can give any name. So even here, when you put args, it means you can put any name. Can you put any name? Can it be A? Can it be B? Can it be args? Whatever. Can it be any name? So let's make like a params. So it doesn't matter how many parameters you will pass. your function will be able to add those numbers. So if you need to check how many parameters you are passing, okay, do something simple like this one. Okay, argument to range or number of elements, something like this one. How do you get this number? You remember this is array. You can simply do the name dot length. So that will tell you how many elements you have. And since you have to calculate sum, yes, you can have a sum initialized to 0, and you loop. You loop for any integer among the parameters you have. You remember this form of loop, for loop. Every integer x in the parameters, I want the sum to be computed as, previous sum plus this x. You remember this notation? This is the same as sum equal to sum plus x. You can use any of the two shorthand operator. If I do this, still it means the sum equal to sum plus x. So after looping, what I will have, it will be the sum. I can return it actually. If I want, I can return this sum after the loops. Is this one clear? I don't know how many parameters you pass. If you want, you can check how many parameters, but this statement is useless in this program because we don't even need it in our loop, but it's for your information to know how many parameters you're passing. Then you can iterate through those parameters, adding each value to this value and saving the results also in this value. In the end, you have the sum of those values. So now if we make a call here, if we come here and make a call to the method, let's say int a equal to what? I make a call to sum and I give these numbers. I should get a equal to 120, right? Because there are two parameters, and one is 40, another is 80. So what if I do this int c and I pass, I say I'm calling sum with parameter, let's say 1, 2, 3, and 4. So still it's okay. So this notation here means unspecified the number of parameters. If I do d and I call it with 20 parameters, still it's okay. Then let's see, system out, print line. I do a, the next one is c space, the next one is d. So here it will display the sum of the two. Next, it will display the sum of these 4, and the last will be the sum of this 5. So if this one works, you can understand how you can pass and specify the number of arguments in Java. So let's save, and let's try to check if a program is okay. Okay, params. Okay, something was expected. Oh my God, what is happening? Should be this one. Okay, now let's do. That's good. Variable sum is already defined in the method sum. We cannot use it because it's confusing. it is here, and it is the same as the name. So maybe let's use a different one. Sum. Rather than writing sum, let's go with S.
Return is written wrong.
Oh, return miss. Okay, was missing a keyword there. Oh my God, was missing a keyword error. So I think this is not a PL because the sum is not reserved the keyword. You can even still using. You can still use the sum, and it should be fine. So error was missing here. So now let's check again. All right. So we put 4. So now you can see for the first time, the argument we passed was 2, 4, and 5, and this is the sum. So let's see the program again. So you can see the first parameters we pass is 2, and the sum is 120. Second is 4, and the sum is 180. 10, 40, 50 plus 50, 100 plus 80, 180, and this is the last. So I think with this example, it's clear, you understand. You can pass any number of arguments, and you should be able to process those arguments and specify the number of arguments. All right. So the other stuff is a common thing that you can, yes, sorting in numbers, finding largest, smallest. Those are the things that we know. Method overloading we discussed, and the passing any arguments, any number of arguments. So with this, guys, we can listen to the questions. Otherwise, this is the end of the session. All right. So we're still there. Let's see.
Yes.
I'm still present.
Yeah, I can save this one. I will share with you the slide, and I think you will tell me which one is better, recording or having a session like this one. So which one is better? Can we? Okay, maybe we need some sort of session like this one, mainly for you guys to tell us the challenges and ask the questions. But even recording is much better. I don't know. You will tell me. So let's end the session by today. By here.
Sorry to
Yes, yes.
I think we can do the session like this and ask questions. Even we can record it as usual, and then share the recorded session with our questions and answers too. Like this one, how we use it. We used to do it. If you are recording and we ask questions, it can be better.
Okay, so let's see, because I will check the record from Zoom if it is really good to record. Otherwise, there is no problem. We can do this. All right.
Yeah.
Okay, if you no questions, I'll be sharing the presentation, and I will check the record. If it is really something that we can share, I will give.
Yes.
All right. So if there is no other questions, let me know, please.